Welcome back to Chapter 5, Ionic Bonding, Section 5b, Ionic Lattices. By the end of this video, you will be able to define an ionic lattice, describe what do the endings IDE and ATE tell you about a substance, and describe how to work out the formula of an ionic compound. First of all, let's examine together what is an ionic lattice. We have learned in the previous tutorials that ionic compounds are those which are formed by the loss and gain of electrons. Whenever an atom loses an electron, like the Na here, it becomes an ion. And whenever an atom gains an electron, like the Cl did here, it becomes an ion. So here the Na, when it lost an electron, it became Na+, and whenever the Cl gained an electron, it became Cl-. Ions, they are held together by strong electrostatic forces of attraction between oppositely charged ions. These strong ionic bonds, they allow billions of ions to be packed together in a regular repeating arrangement. This repeating arrangement is called a lattice structure. And you can see here the lattice structure in sodium chloride. So whenever we have these ions that we have mentioned in the previous slide, whenever these ions are packed together in such a structure, in such an arrangement and a repetitive arrangement, this is what we call an ionic lattice. This is what we call the lattice structure. Ionic compounds actually exist as a large 3D structures known as a giant ionic lattices. When we talk about sodium chloride, there aren't actually any individual sodium chloride molecules. Instead, the sodium and chloride ions are arranged in a regular repeating 3D pattern known as a giant ionic lattice. Let's now have a look at the giant ionic lattice. As you can see here, this is for sodium chloride. We know that sodium and chloride ions are electrostatically attracted to one another. Because of this, you will see that the ions are arranged so that the sodium ions are always next to the chloride ions. This arrangement is seen in all directions of the 3D structure. The electrostatic attractions in a lattice structure are very strong. Let's think about it. Each sodium ion is held in place by the electrostatic attraction of 6 neighboring chloride ions in all possible 3D directions. And similarly, each chloride ion is held in place by the electrostatic attraction of 6 sodium ions, also in all possible 3D directions. Shapes of crystals. Now we're gonna discuss the shapes of crystals. The shapes of crystals are determined by the structure of the lattice. And there are 7 basic crystals or 7 lattice structures. Let's examine them together. The first shape of crystal is the cubic shape. And we have the tetragonal shape, also the hexagonal shape, we have the trigonal shape, we have the triclinic shape, and we have the monoclinic shape and the orthorhombic shape. These are the 7 basic shapes of crystals that we have in chemistry. An example of crystals is the NaCl crystals. Sodium chloride crystals, they are shaped like cubes. As you can see here, these crystals are from a salt mine in Poland, and the largest one has size of 5 centimeters.